All right, I think we should begin. It's about 2 minutes over the hour, and I see about, I think, 10 participants here so far. So let's start. So today in the Oracle Office Hours, we're going to talk about the best practices for developers in the context of Oracle RAC. I'm Anil Nair. I'm the product manager for Oracle Real Application Clusters. And if you have any questions about the presentation after we have this done, feel free to reach me at the Twitter address. I'm usually very good to respond on that. And if you want to get the slide deck, they'll be available on SlideShare, and the video itself would be available on the Office Hours website. So having said that, let's start over with the safe harbor statement. I'm actually not going to talk much about what's future, but still, if I may, then please do take a second to acknowledge the safe harbor statement. And now that we are done with all those things, let's start with the program agenda. So in this session, the real reason why we started talking about what is the best practices for developers when they access a RAC database is to understand for developers what are the RAC data access path. And I kind of go over a bit over these things. I emphasize the need for creating and configuring services correctly, utilizing connection pools, UCP or DRCP. Some application considerations, like in JDBC, is my examples that I've used, but they actually are for most application programming languages. Then how do you identify issues, and what are the possible workarounds that you can implement? So let's start with the first one, Oracle RAC data access paths, right? So for the Oracle RAC, if you look at the layers, usually you have what we call the client tier or the user layer. You have the application tier, and then you have this database tier. So you can tune this on all these three aspects. We have talked a lot about the database tier itself. We talked about cache fusion optimizations. We have talked about, the new features in 12.2s and 18Cs that, help, ensure performance of the RAC database. We haven't talked much about the application layer, especially about connection pooling. And in this session, we're going to talk about mainly client tier and the application tier. Expecting that we will have more on this series, we are going to talk about the three also performance relevant stages. They are the preparation planning, and the test production, and tuning based. So we'll go over all of these different performance relevant stages. Okay. 3 ways to access data. This is something that I'm hoping everybody knows by now, because we've talked about it in the previous office hours. In a RAC instance where you have multiple instances accessing the database from the same database, you will have 4 different buffer cache. What I mean by that is your block could be cached in node 1, node 2, node 3, node 4. So let's say if your query is connecting to node 1, the leftmost one in this slide deck, you could have the first way, which is the fastest way, which is usually what we call accessing data locally. And typical access times is in nanoseconds. So if you look at an AWR report, to access the data which is in the cache, if your query is connected to the same place, then obviously it's the fastest one. The second most is what we call is the remote global cache, where your data is in the buffer cache of the third node in this case. So when you get it, typical access time, because you're sending it over a high-speed private network with very low latency, your timing is in the microseconds. The third one, which we try not to do much, but it is possible that sometimes you have to read from disk, then it's usually considered the slowest. Well, in this, we have some tiers. Like, for example, if you have a flash cache, then the access time is in microseconds. If you have a disk controller cache, then it's still microseconds, but flash cache is a bit better. If it's spinning disk, then it's milliseconds. So these are some of the rough high-level things that most developers are probably not aware of. I know as a RAC DBAs, they're very aware of these things. But it's very important as a developer to understand these things. Why? Because in the rest of the topics, I'm going to talk about how to co-locate your sessions to this data, how to co-locate your application pools and your UCPs and all that. Okay. Again, like I said, for DBAs, it might be very, very, common to know this, but in RAC, we have these three specific processes. So if you look at how RAC SGA is set up, you have this big SGA, which has its components like buffer cache, library cache, dictionary cache, and you have a bunch of these Oracle processes, which are going over the private interconnect to talk to the same processes on the other node. So there are three processes that are very specific to RAC. This is the LMD, the LMON, and the LMS. At a very high level, LMD is the lock manager. LMON is the guy who communicates with the clusterware process to make sure that nodes are part of the, watch instances are part of the cluster right now. LMS is called the workhorse, which is because the LMS is the guy responsible for sending your buffer blocks to the other guys. And we have some slides which talk about it. And just to go understand, most of our tuning is on the LMS side. Now, I have LMS in a red box to kind of denote that it runs in like mostly in real time, and a bunch of them, and it's dependent on the number of CPUs on the system. Why? Because we have seen that it's the LMS which gets most busy, and if LMS is not performing as optimally as it should, then it's not going to be, the performance is not going to be that great. Oh, by the way, I should tell you that my colleague had an emergency, so he couldn't be here. So he's not manning the chat right now. So if you have any questions, what I will do, put it in the chat. At the end of it, I will go through the chat and answer your questions. So, we'll see how we get there. I think I have slides for about 35 to 40 minutes. If you have questions, we'll sit and talk about that. Otherwise, we can always wrap it up earlier. Okay. So yeah, do hang on to your questions or put that in the chat so as a marker so you know the slide number and we can easily get to that. Now, since we talked about these are the three ways to access data, the worst case scenario is what I call the requester, which is denoted by this red arrow coming onto first node, asking for data which is held in a remote instance. The masters are node 4 and the data is in some other instance. So you see that they're all spread all over the place, which means that you got to first from node 1 to figure out where your data is, and we find out the data is in node 3. Now you cannot do anything to that data block because you need to get permissions. And in this case, in order to get permission, it has to send yet another message to the master on the 4th node. And once it gets the permission, it can do what it wants. Now, this is what we call like the worst case scenario. Now, I know I'm not talking about a version specific thing, but if you go to the 9i, 10G versions, then this used to be a bit common. As we get into the optimizations that were introduced in 10G, a little bit of late 10G, 11.2, and more with 12.2 and 18C, there are a lot of these features called DRM, dynamic resource mastering, where we try to co-locate the master with the data. That means the way that we try to spread the master across all the nodes, we try to move it along with the data. So you should really, really not see this scenario much. There's also this thing called service-oriented buffer cache, and we talked about it in the previous office hours. I will just go over it in a bit next slide, but let's for this slide deck assume that this is the worst case scenario, but we try to prevent it. So in a typical workload, when you run it over a period of time and you run your report, this should be very rare, okay? So let's talk about some of the optimizations that help reduce this worst case scenario, okay? Mentioned about this service-oriented buffer cache. What does this mean is we try to improve the performance by moving the data into where it's accessed from. It's very, very simple. So if you have a 2-node cluster, let's say node A and node B, and you are connecting only to node 1 to run your, say, access, which is updating your sales table, and on node 2 you're doing accounting table, then we would try to co-locate some of the buffers related to the sales table on node 1 and the accounting table on node 2. Yes, it's possible that sometimes there will be queries which access both. So we don't do that like for every access. There's a threshold. Once the threshold is hit, we try to move it. And we try to move it so that the application does not get affected by this, in the sense that it's not having to wait. Okay. The other thing that we also have to remember in this scenario is that we also persist this data into the database, which means that if you, say, have a system that you need to patch, so you applied all the patches, shut it down, and start it up again, instead of throwing all the blocks all over the place, we will actually try to figure out that, hey, remember the last time this thing was working, this service sales was on the node 1. So let's make sure that this table is actually more, we try to give more buffers to node 1. And obviously when we do that, we also try to move the lock master of these things to node 1. Okay. The other thing we can do is in this 12.2, which is, this is the, by the way, 12.2 feature, is that if you have a planned downtime, then when you move, what is a planned downtime? Suppose you know that node B is having some kind of hardware thing that needs to be replaced, meaning it's working fine, but the sysadmin says, hey, I need to apply some patch to it or need to change some component. You could move or shut down the database on that side, on node B, and move that service to node A. In this case, what we can do is, remember, node A is actually very, very doing its work, and node B is actually having its own buffers. Now, node B's buffer can be moved to node A. That way, when they move over, the sessions move over, they don't have to go back to reading from a disk, which is very important to ensure that performance is, can continue. And by the way, that's the animation that would, have that the buffers are moving to node B to node A, so that eventually when node B can be patched and then it restarts again, because of this service-oriented buffer cache data that is persisted, these buffers are going to be started in node 2 or going to be touched on node 2, that way is the right terminology, so that when sessions come over, they don't have to go back to physical reads. The second important thing that happens or happened in 12.2 is this thing called LMS CR slaves. So what is this CR slave? Now look at this table on the right-hand side. This table on the right-hand side is showing a table with just a simple table. You have the account information and the amount. So if you take the account information, let's say this is my account, a typical person with a very low account balance. At time T, you have, say, $2,500 in there. And at time T plus 1, you paid somebody, so again it's a minus 500, so you got $2,000. Then again you paid some other vendor, and so you have like $1,000, and eventually by the month end you paid everybody. Now you got less minimum balance left, right? Now what happens is, now let's say there's a query that is requiring this data as of time T, and this buffer is on the remote node. So what LMS does is it says, okay, fine, this guy wants his data at time T, but the current data is only at time T plus 3. Then what this optimization does, or what this CR slave is essentially, if the LMS deems that, oh, I have to apply, in this case, only 3 records, just for illustration purposes. Let's say it has to apply, say, 100 records or 200 records. I don't want to be stuck doing that because there's still ongoing work coming in. So I will actually move this or offload this to a guy called my CR slave, who would apply the undo, and go back until it gets to an SCN that the buffer was. So in this case, since the requester said, I want this data as of time T, which means what is the balance is 2,500. So this is a performance optimization, because without this, if you have LMS and the LMS is supposed to do it, it's going to be stuck doing it. So that means if other guys are saying, hey, I want this block, they're going to wait. and they're going to have to wait until this thing is over. So this optimization ensures that you really try to make sure that LMS is not busy. Remember, we have a lot of LMSs. Generally, in a CPU, on a high CPU system, we have more LMSs. They are running in real-time mode. All this idea is because LMS is generally the most busy, and if LMS cannot do its work, you will immediately see the performance impact. Hence, in this case, we always try to make sure that the LMS is busy. Okay, are not actually in the sense of busy, but it's not stuck. So LMS is fine that it can work on ongoing incoming work, but it doesn't have to be stuck doing one guy's work, because what that means is the rest of these sessions are going to wait, and that's not something we want. Okay, and then there's a default of one slave, and additional slaves are spawned as needed. We also have this undo header hash table. This is a new thing. Again, I've talked about it in the past. I'm just setting up the stage because I think some of these concepts need to be understood, because I did mention at the start what is the worst case scenario and how are we ensuring that we never get into that worst case scenario. We always want the performance or the data to be accessed either as 1 or as 2. Remember, in that 1, 2, 3 ways to access data, third is the worst. We want to prevent the third one. We always want 1 and 2. Okay. So what is this undo header hash table? Now, regardless of RAC, what happens is whenever you do insert, update, deletes, all insert, update, delete, when you commit them, it requires to do undo header lookups. Why is that? Because remember, the undo header has to be seen to make sure the transaction is committed and if there are any block cleanouts. Block cleanouts are necessary when you have a huge buffer cache and you make a bunch of changes in the, in an update. Some of these blocks are not cleaned out immediately, so they are cleaned out at the next time the blocks are accessed. But when you do a commit, and if that block is the one in the cache, then they need to be cleaned out. So there's some lookup that it has to perform. In RAC, this is a bit bad because we have to do the lookups across instances. Now, how would you figure out, hey, am I experiencing this? Well, if you look at your if you look at your AWR report, if you see something there, similar thing. Again, this is taken from a simulated environment, but if you see your data blocks access is less than your undo header access, then obviously this is the problem where your OLTPs are requiring to do a lot more lookups, and they're actually waiting on that, right? So this is not a good thing. You want to make sure that they go as fast as possible. Well, in 12.2, what we have done is you don't have to do anything. It automatically kick in. We actually have this thing called a hash table. So we don't actually have to go across the network. We would just look at the hash table, and the hash table would say, fine, we'll get the data, and then we can continue on. So once you have 12.2 and your application was experiencing this as previous releases, you would see a better performance. You would see the number of undo header lookups reducing, and you would see a lot more work on the data blocks, because this is what you want to see in a very high OLTP system, that you want to do more work being done on behalf of the users. You don't want this background overhead work being done, which is what is the undo header and then the other things that we talked about. Okay. So I talked about a bit, services. I use this term services. Now, I don't know, many developers don't know this concept of services. Usually when a developer asks a DBA, he says, yeah, this is the username, this is the password, this is the host and port, go use your thing and you're all set. Actually, that's not the right way to use it as we get into the 12 and 18C. There were services even in 10, but this using username and all this is a bit older terminology. The newer one is what we call using services, and I keep calling them user services for a reason. So what is a service? Well, as a developer, you don't have to worry, because this is something that it is being set up for you by the DBA. But think of services as just like a logical abstraction that can be used to group workloads and route work to specific instances. So you would have a database called sales. Okay. Now, if your application or you're the developer of an application that does OLTP and you have, say, dedicated nodes, how do you make sure that your users connect to that node is you use this thing called, sales underscore OLTP or something like that. This service will ensure that it is dedicated to a certain node. And if that node goes down, the service can be moved somewhere else. So you as a developer don't need to care where your work is getting done. You just need to know that there is this thing that I need to connect to. And the same thing you use, it's essentially you use a service name, use a host name, use a port name, and you connect to it. Obviously, username, password is always there, but the service is something that you are using so that you can actually route work to a specific instance. The same way, let's say there's another user called sales underscore DSS who could use another service which is obviously called sales underscore DSS, and they could be going to somewhere else. Okay. The big thing or the main thing that if you're the developer and the DBA, you want to make sure that when you create it, you want to use the Oracle home bin serve CTL command to create services. Obviously, you could use what we call as EM or Enterprise Manager. There are a bunch of ways to create service, but if you are using the command line, make sure that you use this Oracle home bin. Why am I saying this? Because there are some cases where your grid infrastructure, which also has a serve CTL, may be running a different version, and you would get this kind of all these problems where your database home may be a lower version and may not be ready to do things or have the extra commands that might be there in the GI version. So always make sure you set the environment for your database home and use it to create services. The other thing that is a bit tricky is by default, we'll create the database. When you set up an installer database and you create a database, a default service is created for every RACDB. The problem is this cannot be altered. Like you cannot drop it or anything, and it's for internal use. Like typically guys like Enterprise Manager uses it. So this is a bit convoluted in the sense that we create a service, but that service is just for our use. Customers or users need to create their own service. Okay, so how do you create a service? You would create a service by doing what we call as servctl add service, and that's obviously you give the -db cloud and minus service cloud and minus server pool. Obviously if you're using policy managed database, you can use that. Now what happens? Remember this, I just said that you cannot create a service name called cloud for a database which is cloud. So obviously this will fail. It would say something like the cloud.us.oracle.com cannot be used, blah, blah, blah. They'll get this error called PRCD1210. And again, if you're aware that Oracle has this command called OERR by which you can get the information about the error. So you could say OERR, you pass the PRCD and the error number, you would see this. The service number name cannot be same as database name. So again, you create a unique service, call it whatever you want, but it cannot be called the database service. Okay. Now you could have certain services. They could be singleton service. Okay, a singleton service is what we call, which runs only on one instance. For example, if you're a 4-node cluster, or you would have the singleton service, which could be on node 1 for today. And if node 1 is going down for something, it will go to node 2, but it will only run on one node. Okay. You use this singleton option when you create the service. You could either do it during creation or you modify the service. There are these entities called RLB and CLB, right? Runtime load balancing or connection time load balancing. Again, we will talk about this in the next slides. If you're using XA transactions, then you can enable them for the service. And this is probably not much I'm not going to get into because I haven't seen a whole lot of customers using XA. But if you have questions, like I said, feel free to send it to me. We'll make sure we'll answer them offline. So like I said, there are various ways to create services. You could do it on the command line, So this is one of the options you have. You have create service. You could do cardinality. This is the one where I said you could either have uniform service, which means it's all over on all the nodes, or you have singleton service, which is on one node. The role of the service could be either primary, it could have a physical standby, all those things. Obviously, you in a RAC environment without any data guard, you would just have the role which is primary. You could have a policy where you say, I will start and shut down my database. I don't want anybody else to do this for me, which is in this case manual. Or you could say, hey, you know what? Please, clusterware, you take care of it. What that means is we will manage your service. In case of singleton service, we'll move it to another node if possible. If the node which is hosting it goes down for any reason. Connection load balancing goal. We'll have this short or long. Again, we'll get into a little bit later. You have this failover types, which could be for session level failover, select, or transaction. Again, I'll go into that a bit more detail. Same for CLB, we have a runtime load balancing goal, and the same failover method for that. And you could have service for certain pluggable database. So if you do -PDB, then that service is for that PDB. Okay. And so here's some examples. So you want to call these things like this. So you've got servctl service -DB sales, and the service is batch, which is running at night. That's very good explanation in there, so you know what's going on. And you could have something which is service OLTP, which is running in the daytime. Again, these are implementation details. You could have services which are running in batch on a lot more number of nodes, because obviously we are expecting that OLTPs are not that busy at night, and vice versa for OLTP during the day. You want to have more OLTPs running on more nodes and lesser batch, right? So again, this is just a typical example. So when you create a service, this is how it will look like. So for example, in my example, I've created this service on 4 nodes. And these 4 nodes, I have email, which is running on all my nodes. Okay, so that means my email service, when you connect, it would go to either of these nodes. Sales DSS would go on node 1 and 2, and OLTP would be on node 1. Again, this is just an example to kind of highlight how this all works. The OLTP service, because it's running on 1 node only, I've created it as a singleton service. DSS is a uniform service running on 2 nodes, and email is uniform service running on 4 nodes. In this case, how does this load balancing work? So this is set up by what we call as the client-side load balancing. Now remember, there are a couple of load balancing things that kick in. When you connect to the scan as from the client side, from this either using the TNS names, or you're providing it as a URL for your program, you could have this option. Now what happens when you set this up is the scan, which is an entity which we pre-require you to create it. Like usually, again, the developer is not concerned with this. A DBA would do it. And essentially what scan is you would get different IPs for the same host, and these IPs are maintained by Oracle ClusterWare. So when you get incoming connections, so if you look at this bottom of the thing where there's an arrow where all the connections are routing to the scan, and you have this email running on these 3 nodes, then if you look at the animation, nodes, they will be, the connections will be sent only to those nodes. Now, that way, we're kind of trying to make sure it's load balanced. In this case, it's more like connection load balance. What that means is we're kind of going and spreading them across based on the number of connections. Okay. You could specify options where, remember, the scan, although the scan itself could be running on, say, node 4, it knows where the services are and could reroute those to the right node. You have a choice. You could have what we call as the load balancing option could be short or long. Okay. In this case, if you do this as a CLB to be short, then we influence the connection to an instance based on response time or throughput statistics. Okay. If the long means typically it's used for batch applications, which means you typically want to do it because when you send so much work to a node, you don't know over a period of time, if you send, say, first batch application, second session, third session, fourth session, that might actually do a lot of work and get busier. So you want to specify the load balancing goal in that as long. The short is all obviously for OLTP, because OLTPs generally do small work and they're more rapid. So you want it to be routed and to the least busy node. Okay. I really didn't want to talk about this. This is something I really think should be not there anymore. But I had received some questions on this a couple of days back about what we call as a transparent application failover. And if you've been around since the 9i timeframe, there's this entity called transparent application failover, which kind of tries to, in the past, remember, it was a new thing at that time, and so it's very unique, even though most people today would think of it like, wow, what an arcane thing that was. It was actually working at that time. Yes, it has its limitations, but it was a unique thing in the sense that if you are connecting to a session, a session to a node, if that node or instance fails, if it is a read, you could actually connect to the other node and it will continue. It was, again, I cannot emphasize, a lot of people do not like it now because obviously there's a lot more things like what we call application continuity, and this is what you should be using if you are going to be 12.2 and 18c. We talked about application continuity in the last office hours, and the video and the session is uploaded there. So if you have questions on that, please go look at that, and obviously you can feel free to reach me. But this is, again, just for those who are still having some older sessions, older database versions, and still want to have a few questions on that. Now, again, the graphic shows that you could have what we call as users directly connecting and utilizing what we call TAF. You could go through a connection pool and still be able to do some of these things. I'll be honest and say, if there was anything, like for example, failing in that, if the application returned an error or the application couldn't handle that server-side error, you would get some ORA or TNS errors, and this was one of the things that customers didn't like. It did provide what we call as CTCF and RTCF. That means it's connection time, connection failure, and runtime connection failure. And again, I break this down a bit, but again, like I said, this is more for people who are using an older release and they're stuck with it. They still want to know, and obviously, we want to help those guys too. Okay. Then came this thing called as a fan. Okay, the fan is more like a 10.1, 10.2, 10.3, 10.1, 11G, and 12.2. In fan is a bit more, easier to understand, in the sense that fan, or what we call as a fast application notification, it wants to inform clients ASAP. So how does it do that? A fan event is generated from the clusterware side. A clusterware is aware of nodes leaving or joining the cluster, instances stopping or instances starting, and fan just sends out an event. The event is more like can be consumed or can be ignored. And if you're using a fan-aware connection pool, or if you're using a user session which is fan-aware, then it can react to it. So you would be able to do something. Suppose you're connected to some node 3, and if node 3 is crashed or node 3 is going down for any reason, a fan event can be consumed and the application has a choice to connect somewhere else or do something what it wants. Okay. If you look at a connection pool, now again, I keep saying connection pool and direct connect. I think developers don't need to be told this, but just for the sake of completeness, I'll just talk about this. If you want to develop highly scalable applications, you do not want to connect individually. So the worst thing that you can do, and again, this is regardless of database, Oracle or RAC or even any other thing, but if you ever try to create a session, creating a session is actually a bit expensive from the operating system side, because there are a lot of back-end work that has to be done. The back-end work includes creating a new process, associating all the memory. It has a lot of work, and this is actually a bad thing. So if you have, say, a session that connects and disconnects, say, 100 times in 1 minute or 1 hour, it takes a lot of effort on the operating system. you really want to do is you want to use this entity called as a connection pool. So what is a connection pool? A connection pool pre-creates connection to a database. So in this case of RAC, you see that you have 6 connection pools or connections in the connection pool that is spread out across the RAC nodes. If somebody wants a connection, it comes to the connection pool and says, hey, I need one connection, and then one connection can be used by that guy. When it's done, he can give it back to the pool and somebody else can use it. This is really a cool optimization, because if you see, and I've seen some applications where about 20 gig worth of memory was used by just this application sessions, because they're constantly connection creation, and then sometimes they just even hold on to them forever, even though it's not doing active work, right? So because this connection pool is fan aware, so if you look at this, you would have this just 3 sets of connections of 2, and let's assume that they're all connected to 3 nodes. So the leftmost connection pool is connected to node 2, the middle one node 3, the rightmost one to node 4. But what happens if any of the node fails? Then we actually update the connection pool ourselves. So when an application user or session comes and says, I need this connection, says, oh, actually I'm not going to give you those which we know are stale. We'll give you something which we know works. So this is actually a very cool thing, and that this optimization or this usage will ensure that you do not actually go and use something which you're not supposed to use and then wait for TCP timeout and all that. Okay. We talked a bit about connection time load balancing. So connection time load balancing is a bit interesting. So in the previous releases, there's a process called PMON, and it's actually in 12C, we have this process called LREG. We dynamically register the services to the specified listeners. Now, we provide a lot more information than just registering. We provide them, the listener, with the information, like in 1 minute OS load average for all 30 seconds. So for you, we get a moving average so that we can determine whether that node is busy or not. We also report the number of connection to each instance. So if you have a 3-node cluster, for example, if email is running on 3 nodes, and let's say node 4 has 100 connections, whereas node 2 and 2 and 3 has 10, then this information is aware with the listener. So when the next session comes, it knows what to do based on what you define. So if you have defined connection time load balancing, then we'll make sure that, hey, we need to send it to a node, because we are making sure that it is an equal distribution of number of sessions. So how does this work? So there are, like I said, there are 4 possible things, right? You could have connection time load balancing, which means it's a new connection coming in. It could be connection time, but there was a failover, and that's why it's there is a new connection moving to another node. The same thing when you have runtime connection load balancing or runtime connection failover. Now, take this example here. You have this connection pool, which is having, again, 6 sessions. If you have 3 nodes, if the first node says, I am busy, please do not send me more work, it will get probably or continue to have what it had earlier, which is 30% connections. These instance 2 says, I am very, very busy. Don't even think about it. So it may get 10% connection. Instance 3 may say, hey, I'm not that busy. I'm actually idle. So you get 60% connection. So this is how we make sure that when a session comes in, the connection pool at that level will even know this information, so that when we give that pool or that session, we take the session, when we give a connection to a session who's requesting a session at that time, all these things are taken into consideration. Okay. There are 2 different aspects of FAN. There's another thing called as a fast connection failover. In this one, we call it, there are 2 things called unplanned and planned. So difference is essentially, unplanned means it was unplanned in the sense, hey, the node just had a power failure or something else, something that you didn't plan for. Because of these events that we invoke, we could actually now have this session move over very quickly. So let's say you have this user who's connected to node 2. If there's a problem with that, you could actually get very quickly notified and could connect to node 3 very quick. Like I said, this supports both planned and unplanned. In this case, and the example, we are looking at unplanned. We also recognize that if that happens, and at that time there's a newer node that is joining the cluster, we recognize that we can distribute runtime work to all active instances, again, based on how busy they are, right? So this is something that works much better than TAF, and it is able to utilize what we call as these cluster-aware events to rapidly move work and detect failure. Detect failure and move work to other instances. Okay. So what happens in planned downtime? Like, for example, let's say you are using rolling choices to move work away from the server. Like, this is the example case where I say, how do you plan to shut down a node, let's say in anticipation of you want to change some component. Okay, this node is working fine, but your SA says, hey, I want to apply a patch to it. It's a security patch. Can you move work away? In the past, without this, you would have to stop this instance, sessions connecting to this would have to actually figure this out. And yes, it would work. But when, let's say, a busy node gets down or has to be brought down, suddenly a lot of work has to move. Instead of this, you can do what we call as phased move or called draining or called workload draining. So on this animation, you can see on the right-hand side is the connection pool. The left-hand side is the instances. Kind of color-coded it. Again, I don't know how much zoom deteriorates the color, but the 1, 1, 1, 1 in the connection pool are connections to instance 1. So they're kind of this blue color. The orangish yellow color is the instance 2, that is 2, 2. The black is 3, 3. And then obviously the singleton one, I did not have, just to make it easier, I just put 1 only there. So what would happen is, let's say you need to take something down, that is the instance 1. When you shut down instance 1, what needs to happen is you have these 3 connections still in the connection pool. What would happen is, first of all, we would stop sending work. These connections will be migrated into another session. So in this case, if you remember, before the animation, it was 1, 1 in the first 2. It became what we call as 3 and 2. So we did move a lot of sessions, but there's this one persistent session that's not moving. What can you do about it? Well, there's always this one guy which is not going to allow you to do this planned failover. You could actually do DBMS service.disconnect session, and that would ensure that it moves to the other instance. Again, there's just a animation to show. You want to test this out in your application. Make sure you find out what is causing some of these sessions not to move. And essentially, they will be using something where they are not using connection pool, or there are developed sessions, application sessions. They connect and don't do any work. That's actually not a very good thing. You could connect, you want to do your work, and you want to give the connection back to the pool. Which gets us into the section on utilize connection pool, which is called UCP and DRCP. I talked a bit about this. Always want to use connection pool because there is a TV connection is a bit expensive. There are a lot of work on the OS side. The second thing is it's expensive even to kill those sessions. When you stop or when you disconnect the background session, when they are removed, it's actually expensive. There's a lot of CPU time spent by the system to do that. And repeated connection disconnection, I tell you, every time I look at a application performance issue, we see this a lot where somebody is just doing connect, disconnect, connect, disconnect. You want to make sure you use the right architecture. Now, which one is right, we don't know. We'll talk about it. We'll introduce all of this for you. It's up to you to choose as a developer, whether it's a dedicated server or you want a shared server, or what we call, it used to be called MTS, multi-threaded server. We have this connection pooling called universal connection pooling, or we have what we call database resident connection pool. What is database resident connection pool is, if you look at your application, which is depicted by the host on the top, they come to the connection broker and they take this connection. We would have a pool of these dedicated ones. We would actually use that such that, when you could either come to the, our broker and get this, or you could get it directly from the pool. You don't have to worry about connect and disconnect costs because obviously that is taken care by the DRCP. It's low latency and performance of dedicated servers, so you don't have to worry about this being an additional performance overhead. And it's really, really scalable because, again, you are not spending time on this creation and deletion of these, background processes. This is a very, very old test that was run in this a PHP application. When you use on the left-hand side what we call dedicated servers, you would end up getting 21 gig because there are 5,000 sessions using 4 MB, and then the session memory is 400 KB. So if you add that up, it comes to 21 gig. Take my word on that. On the right-hand side, when they used DRCP servers, the total memory was only 610 megabytes. So you see, it's much more easier to scale with this because if you have, let's say, the physical server, the application server was 40 gig or 50 gig, you have a lot more room to grow. And this is the most actually scalable way to grow. So this is a kind of an example of how to code and how to think about coding and using a specific architecture instead of going, hey, I want to update this database record. I'll go connect, update, commit, and disconnect. Rather than that, use these kind of optimizations which will help you to scale. Okay. Again, these are some of the things. Which one should you use? Dedicated versus shared versus DRCP. They are self-explanatory. I'm not going to get into each of these guys, but obviously use DRCP when you have lots of clients and you need to do this constant, go into database, update, come out, commit, and come out. How do you do this enabling? Well, you have this server equal to pooled thing in the URL, or you could, in the connect string, I'm sorry, and then if you're using the short URL, you could use this :pooled. I'll show this as an example here. So in your TNS, you could use this server equal to pooled option, if you see. Or if you're using the small URL, which is the host name, port name, and the service name, then you add the dot or :pooled in that. The UCP option, well, UCP, again, we support any kind of Java connection. Because again, it utilizes some of the clusterware events, so it supports a lot of the RAC features. It is able to utilize like the FAN, FCF, or RCLB, and you can also have transactions-based affinity for the X8 transactions part. How do you use this? Well, when you create a pool, again, your application may have different requirements. For example, customer A might say, hey, I just need 20 pools or sessions in my pool. So you can set the initial pool size, set the min pool size, max pool size. Again, these are for a large corporation, large application that might require you to set this up to a larger value. And obviously for smaller ones, you might want to make sure you have the right pool size. And this is very important. If you have a max pool size or minimum pool size of 50 or 100 and you only use 2, well, obviously it's an overkill. Okay? You have this set time to live, set abandon, connect timeout, all this set up appropriately in the connection pools, not in the database, in the application tier. Okay. You can also enable what we call as the statement caching, which means these pools can use the statements cached, and you can set the max number of statements that can be cached in there. Application considerations. Well, this has nothing to do with RAC, but I've seen this actually affects RAC also. So try to make sure you're, parsing correctly. Again, if you're a DBA, this is very apparent. If you are not, as a developer, we'll talk about it. Parsing is how an SQL statement is, broken down so we can figure out what it exactly needs. So if you do a select employee name from EMP, we know that, okay, this guy is looking for EMP name from EMP table. Obviously, the parsing comes in where you have the where clause. If you say where EMP equal to 15, if you hard code it, well, then it's a bit bad. And therefore, we want to use soft parsing. And I'll talk about that. So here's an example, a hard parse. It is, if you do a query in your JDBC Java program, where you say select employee ID, last name, salary, blah, blah, and this where employee ID equal to generate something. This is a bad thing. You want to make sure you set the query as in the one on the bottom where you say employee ID equal to question mark, and then you set that, that way when it goes to the server on the Oracle server side, it will be more of a soft parse than a hard parse. Okay. And soft parses are much easier. We can reuse the execution plans. If you have a good execution plan, that can be good, because if you have hundreds and hundreds of these guys coming in, they are going to use the same execution plan. Okay. You can even cache the soft parsers, like I talked about, statement caching. You can also cache, these soft parsers, and obviously these can be set at the connection pool level so that you don't have to do it at individual levels. Again, I know these are some basics thing, but this is very important because people do not do this often, which is to make sure that if you're selecting more than one row, you need to really set it into an array rather than do one by one, because you do not want to go back and forth, especially in today's world where you're connecting from a desktop and it can be routed into the cloud. You don't want to go back and forth, because the network bandwidth and latency will be actually very slow. So you want to make sure you get a lot of the data on the client side, and then you do a lot of the caching there and do your work there. And again, another example where we talk about how you do updates. Instead of doing updates with physical values, you want to make sure that you run this in a loop. So, and ensure that this is all done in one shot when you do the execute batch. Finally, we want to talk about identifying some issues. Regardless of RAC, I know this is a big thing in RAC, and this animation is depicting what is happening is, if you have one block or one row that you're constantly updating from multiple instances, it's a bad thing. Now, forget RAC. It's also bad for single instance. Okay, it's never going to scale. Anything that doesn't scale in single instance, it won't scale even in RAC. Okay, so really bad application design. There are various ways you can solve it. You could use, if it's just a, if you are using what we call as a Boolean update to change some specific row, then you want to not move away from that design. If it's a sequence or something that's an incremental number, you want to use a sequence, which brings us up to the second one, optimization, or what we call avoid the hotspots in application. You want to, if you're creating a sequence, you want to not use, what we call as an ordered sequence. It's not a good idea. So in RAC, what we suggest, even again, I know I talk about RAC, but this is also for scalability. You want to use non-ordered and cache sequence. And otherwise you'll see what we call an SQ contention. You would see that in the AWR report. Ordered does not scale well, so you don't want to do that. In 18C, there is this thing called scalable sequences. I have written something about it in my slide share. You can read up on that. There's a lot more details, but it's a really, really newer thing in 18C where we try to improve the scalability of sequences, especially when you're generating it from multiple nodes. Okay. Obviously, you can alter sequence. You would go from your 12.2, you upgrade to 18C. You can do an alter sequence name, and then you can use the scale option to make it a scalable sequence. This, by the way, is one of those optimizations which you have to do manually. Okay. You want to also reduce your brownout by avoiding hotspots, in the sense that if you are updating, inserting a lot across all the nodes, you want to also make sure your fast start MTTR target is set correctly. Now, again, this is not a developer thing, but you want to talk to your DBA. They have to be aware that this is something that is set correctly. Because what would happen is, if you're having a failure and that failure requires a brownout, and the more higher the brownout, your session is going to wait for more time, and you want to reduce this thing. Okay. You can do a lot of things for this. You know what we call as set fast start MTTR target, or mean time to recover target. You want to get your redo logs being on the fastest medium, which is essentially SSDs. Exadata already has this smart logging feature, so you don't have to worry about Exadata if it's configured correctly. It's going to be working by default, having the redo logs on the fast SSDs. ODA obviously uses SSDs again. It's very important, but schema tuning is not that difficult. Whenever people say, oh, I need to change this, it's a huge change. But if you're not planning your application for what we call as scalability, it will never, work out. You might be able to scale. It doesn't have to be, forget RAC, even in single instance. You got to think about how do you make sure that what works with 1 or 2 users can scale up to hundreds and hundreds of users. Okay. The other thing that you can use is, in indexes. Typically, we have seen hot blocks are usually caused by indexes. When you add or insert rows in an OLTP application, sometimes the indexes need to be split. And when that happens, then you need to, the index splitting has to take a lock on the entire thing, split it. It kind of what we call introduces outliers in the performance. So you really want to ensure that this is not happening. There is this thing called global hash indexes. So instead of using the regular index, you can actually use what we call as a global hash partition index, which will help a lot in this, in this kind of applications. You could drop unused index, especially on Exadata. If you're not using too many indexes, you don't need too many indexes, then you can use it and drop it. This will greatly help with your scalability. So this is something that you want to also avoid on sessions, in the sense like instead of going through having individual sessions connecting directly, you want to actually go through a connection pool so that you do not go directly and then have these servers themselves being busy. I think this is one of the last slides, so I am going to now just give you an example or actually a very interesting YouTube video, which is done by what we call by our own real world performance guys. Please, again, it is not specific to RAC, but you really want to go through how do you develop stuff or how do you develop applications to benefit from the Oracle database performance features. Oracle database, along with RAC, has a lot of features to ensure that your application performs as good, best as possible. There might be things that you can actually do to even make it even better, rather than just dumping everything onto the database. And this actual YouTube video does a lot, good job of going through and explaining all this stuff. I think top of the hour, I would take some questions, but I could see one question maybe. Let me just see. Well, the question is essentially saying, is there an advantage to using the listener service name to serve CTL service name? Well, actually, it's a logical abstraction, like I said. Eventually, it is telling you how to get to some place. There is nothing called an advantage, but you definitely want to use your serve CTL service name. It will automatically in the back end get you the right service that you want to connect. Other than that, I don't see any questions. So I will actually stop this session right now. Thanks again for attending. Appreciate you spending your time. We will post this presentation and the video very soon. Have a good rest of the day, and I'll talk to you next month.